Welcome to this Maths Made Easy video on integration. And to start with, let's just discuss the idea that integration is the inverse of differentiation. Now, this is the fundamental theorem of calculus, so integration is the inverse of differentiation. Now, for example, we know the derivative of x squared with respect to x is 2x. So what this means is the integral of 2x is x squared. So just noting that down here, d by dx x squared gives us 2x. And what that means here is if we integrate 2x, so we integrate 2x here with respect to x dx, that would give us x squared here. Okay. It's important that we don't forget the dx here. This will be important in later sections. However, this definition of integration that we've just given causes a slight problem. For example, if we were to differentiate x cubed plus 3 and x cubed minus 19 here, notice they would all give us 3x squared. So if you differentiate all three of these functions here, or expressions, with respect to x, they will all give you 3x squared. So here, the question is, what is the integral of 3x squared? Well, in this case, would it be x cubed? Would it be x cubed plus 3? Or would it be x cubed minus 19? And under the definition that we gave at the beginning here, it would technically be all three. So here, we define the constant of integration. So in that case, if we integrate 3x squared with respect to x dx here, this will give us x cubed plus c. Okay, and c is our constant of integration. And c represents any constant because all constants differentiate to 0. And we do this for all indefinite integrals. And remember, an indefinite integral is an integral without any limits. So that gives us everything we need there for integration being the inverse of differentiation. Moving on now to take a look at integrating a polynomial. So to integrate something of the form xn, if we want to integrate xn here, then we simply add 1 to the power and divide by the new power. And what that would give us here, so if we integrate xn here, this would simply give us 1 over n plus 1, or we can write this as x to the n plus 1 over n plus 1. Okay, and here as we have no limits, don't forget we'd have our constant of integration. That's our plus c there. And don't forget, we're integrating here with respect to x, so that's our dx there. So that's our general result here. And as with differentiation, we can integrate term by term. And the integral of n times a function is n times the integral of a function. So we can use linearity there. So that means we can now integrate polynomials. So for example, if we want to integrate here, and let's do this in a different colour to make it clear. If we want to integrate x squared plus 3x plus 4 with respect to x, then we just do this term by term. So here we could split this up into 3 separate integrals. So this would be the integral of x squared with respect to x plus the integral of 3x with respect to x, and finally the integral of over there with respect to x. Now here we can also apply linearity if we want to. In regards to this 3x here, we can bring the 3 out in front of the integral, so we're doing 3 lots of the integral of x. We can absolutely do that, however, it's not necessary, and I won't perform it through this integration here. So I'll just be integrating now these 3 separate integrals. So in this case, the first integral here of x squared, well, that's simply going to be add 1 to the power divided by the new power, so that's going to give us x cubed over 3, or a third of x cubed. Okay, so I'm going to write that as x to the 3 divided by 3. Okay, moving on now to our second integral here, so the integral of 3x with respect to x. Again, we just simply add 1 to the power and divide by the new power. So in that case, we're going to get 3 over 2x squared here. Okay, so plus 3x squared over 2, or 3 over 2x squared. Again, absolutely fine which way you give this. And then finally, this integral here of 4 Well, if we integrate this with respect to x, then that just simply gives us plus 4x there. Okay, that gives us plus 4x. And again, as our original integral here had no limits, it's an indefinite integral, we can't forget our constant of integration. That's very, very important there. Okay. Now it's important to note that our rule works for anything of the form x to the power of n, not just positive whole numbers. So we're able to integrate far more than just polynomials. However, it's important to note that this does not work for n being equal to minus 1. So let's just note that down. But this doesn't work. So it doesn't work for n being equal to minus 1. And the reason for that is because it would imply here, or it would mean that we're dividing by 0. Okay, so it's important to note that here. So that gives us everything we need there for integrating a polynomial. And finally, let's take a look now at finding the constant of integration. Now sometimes you'll be told that an integral passes through some given value. And based on this, we might be asked to find the constant of integration. So we've got this example here presented on the screen. And what we want to do is find f of x. So all that means here is we want to find the function f of x, and to do that we're also going to need to find the constant of integration. Now to start with, what we've got is f prime of x. So here what we need to do to get f of x is integrate this. So here, if we integrate 9x minus 5 with respect to x here, again we could just do this term by term. This is the integral of 9x with respect to x here, dx. This is minus the integral of 5 with respect to x. Okay, and here, integrating these now separately, the integral of 9x with respect to x would give us 9x squared divided by 2. So add 1 to the power, so that gives us x squared, and then we divide by the new power. And here, this is minus the integral of 5. And if we integrate 5 with respect to x, that would simply give us minus 5x. Okay. Now here, as we have no limits on this integral, we need our plus c. Okay. That gives us plus c there. So in total, what we get here for f of x here is 9x squared over 2 minus 5x plus c. And what we've been told is that the curve y equals f of x passes through this point here. So we know the x coordinate is 8 and the y coordinate is 200. So in that case, what we know then is f of 8 is equal to 200. So we can simply use this fact here that f of 8 is equal to 200 to obtain the value of c. Now what we simply need to do here now is substitute x equals 8 into this expression here and set this being equal to 200. So in that case, if we do this here, what I'm going to get is 9 lots of 8 squared. So therefore, 9 lots of 8 squared divided by 2. And I minus 5 lots of 8 here. So minus 5 times 8, and we have plus c. And this is all equal to 200. So to start with, 8 squared would give us 64, and then we times that by 9 and divide it by 2. So if we just finish this up here, what I get first is simplifying this part here. So 9 lots of 8 squared divided by 2. That will give us 288. Okay, and again, just use your calculator to simplify all this. Minus 5 times 8 would be minus 40 here. And finally, we've got plus c, and this is all equal to 200. Now from here, if we simplify the left-hand side, we get 248 plus c is equal to 200. Remember, what we're looking for here is the constant of integration, so that's this c here. So therefore, to obtain c, we just subtract 248 off the left-hand side and the right-hand side. So we obtain c is equal to minus 48 there. So we obtained the constant of integration now. All we simply need to do is replace our c value here, minus 48, into our expression for f of x. So if we give this in a different colour, just to highlight this is our solution. So therefore, for f of x, we simply obtain 9x squared over 2 minus 5x, and finally our plus c, which is minus 48 there. Okay, so that gives us the solution to our example, and gives us everything we need for finding the constant of integration. And that concludes this Maths Made Easy video on integration.